Hi, this is John Block with Mr. Block Tutors Math, and today we're going to look at how we can solve exponential problems using logarithms. Let's get a whiteboard here. By the way, there's my website, www.mrblocktutorsmath.com. If you need help with skills or homework or concepts or test prep, look me up on this website. How do we solve a problem like this where we've got 3 to the x equals, say, 6? Well, we can do a lot of guessing on it. I mean, we know that 3 to the first equals 3, and we know that 3 to the second equals 9. So it's got to be somewhere in there. So we say 3 to the 1.5 and take our calculator. So if we have 3 to the 1.5, we should get about 5.1961. We could get closer. We could say 3 to the 1.6. Just try it. Just guess and try, and we get 5.7995. We could try 3 to the 1.7, and we'd go over 6.473. Maybe we'd settle on 3 to the 1.64, and we'd get 6.060. Now you could put that into your calculator and you'd get about that, but it's kind of a long situation. Here's how we use logarithms to solve that problem. I'll just erase all this scratch work there. What we do is we simply take the log of both sides. Now, if I put the word log in there, that means I'm taking log base 10. And how we do it is there's a rule that says the log of, say, a to the x equals x times log a. Now, that's the rule that's going to allow us to solve this quickly. So it looks like that x, that's an exponent of a, comes down in front of the log a. So this x right here will come down in front of log 3. And then I've got log 6. That's a 6 right there. So then dividing out the log 3, I've got log 6 over log 3. Go ahead and see what you get when you plug that into your calculator. What do you get? And you should get something like this: 1.630929754. You could do a check of that and actually plug that back into your calculator. 3 to the 1.630929754. And you should come back with 6. Check. Now, why is this true? That's what let's investigate next. Why is that true? So here we have log base b of x to the n. Okay, now let's develop this argument. So suppose that we'll say log base b of x. Whoops, that should have been a b. Back here. Log base b of x equals m. Well, exponentially written, that would mean b to the m equals x. So b to the m equals x. Okay, then that means if I go back here and replace x, I'll have log base b of b to the m and all of that to the n power. which is the same thing as log base b of b to the mn, which is mn. Because I'm saying here, what do I raise b to get b to the mn? Well, obviously mn. You raise b to the mn to get b to the mn. Now let's turn that around using my commutative property. So back to this though, what was m? We suppose that m was log base b of x. So then let's replace m with log base b of x. There you've got it. So log base b of x to the n equals n times log base b of x. Do you see it? I started out with this, log base b of x to the n. I ended up with the n out in front. There, we've just proven our rule. So now let's go back to a practical example. Suppose I said I knew that 5 to the x equals 24. Well, you know it's got to be, x has got to be somewhere around 2. So what I do is I take the log base 10 of both sides, and according to this rule, this x can come out in front. So I rewrite it, x log 5 equals log 24. Divide out the log 5, and I've got log 24 divided by log 5. Now take your calculator and go log 24 equals, and then divide log 5 equals, and see what you get. Go ahead and do that. Okay, I rounded it off. I got 1.9746. Let's do a check on that. Take 5 to the 1.9746, and I get approximately 23.9886. Check. I'm a little off because I rounded. See how that works? It's a very slick way to find an exponential problem. This exponential problem being 5 to the x, finding the x of 5 to the x equals 24. Now here's another problem, just slightly harder, but let's just use the same technique. So if I take the log of both sides, the log base 10 of both sides, and I end up with x plus 1 in front here with log 5 equals log 13. Divide out the log 5, which you should get, and then we have x plus 1. So log 13 divided by log 5 is 1.593692641. Subtract 1 from both sides. We could take a check real quick and do that. So see if 5 to the 0 point, well, it would be plus 1, so it'd be 5 to the 1.593692641 does that, and it should equal 13. And you can check me out on that using your calculator. Back to, this is John Block from Mr. Block Tutors Math. If you need help with skills, with homework, with concepts, with test preparation, I can do all that for you and help you with that. So look me up on the internet, Mr. Block Tutors Math. Thanks. We'll see ya.